a mission to Venus. When do you think I'm talking about, and how much do you think it's costing?
$1.
I can always count on you for the, the best possible answer.
$500 million, and yeah, it's 4 years.
Okay, actually the answer is next month.
Oh, no.
And the answer is $10 million, by the way. So, and this is going to Venus. Now, it's not big. Obviously, this is not to scale. That thing is not as big as And this is Rocket Lab. It's a private mission. That's the other thing. This is the first mission to another planet run completely as a private mission. And it's on Rocket Lab, which only makes small launchers. This is kind of interesting. Anyway, why are they doing this? Well, they want to look for organic materials in the cloud droplets, traces for life. And that actually isn't as crazy as it sounds, partially because of the fact that, okay, on the surface of Venus, it's ridiculous. You know, it's just hot, high pressure, sulfuric acid is a mess. But if you're up in the clouds, there are places, you go up high enough, it's similar conditions to Earth in terms of temperature anyway. You still got that sulfuric acid, but at least you have temperatures reasonable. And people have theorized at some point in the past, because you had oceans on Venus, you know, there could have been life that evolved there, and maybe it survived up in the clouds because you have a heavy layer of clouds. In some areas, it's cool enough, you know, life could have gone on or could have evolved, you know, there in any case. So they want to go find that out. And Rocket Lab kind of wanted also a little bit of PR to highlight their spacecraft ability. Instead of throwing a Tesla up, they decided to do something, you know, that it might actually provide some scientific value. And so that's what they're doing. It's a private mission to another planet. No, actually, they will not detect phosphine, but they will detect a lot of other things. I'll get to that in a minute. But phosphine specifically, they won't even recognize. But why Venus? Okay, as I said, once upon a time, it had oceans and much more moderate temperatures. They think it probably had kind of a runaway greenhouse effect. Nobody really can know because it's just so hard to tell what's going on there. Anyway, as I said, the phosphine detection, that turned out was probably a false alarm. But the thing about phosphine is, on Earth anyway, most of that is generated only through biological processes. I mean, okay, a chemical plant can make it too, but for it to occur naturally, it's typically biological in origin. And that's why people got excited. There was a big fuss over this some years ago. It turned out it was probably a false alarm, but, you know, people aren't 100% sure. And so this is a way to find out more. So their goal is to get to about 30 miles altitude. That's where the conditions are probably close to Earth. Reasonable temperatures, reasonable pressures. So how do you get there? I mean, we're talking about an Electron rocket. I've done a lower left corner of the slide here. I'm reminding people 59 feet high, that's nothing compared to the 400 feet of Starship, for instance. For a low Earth orbit, it only puts up 660 pounds, and obviously it's going to be a lot less than that to Venus. How are they going to do that? Well, they're going to do the same thing they did on their last lunar mission. They have already done one lunar mission. And they're doing exactly the same thing that we talked about with the last Indian lunar mission. Basically, you get up to low Earth orbit, and that's shown in this diagram here. Typically, your orbits are somewhat elliptical. They're not really perfect circles. But usually, when you're closest into Earth, that's when you're going the fastest. You know, if you think about the way the mechanics work out, when you come in close, you're going really, really fast, and then you go really, really slow in this big loop, and you come back around. If you're going to apply thrust to go faster, you want to do that at the point where you're going fastest. And that's right there when you're closest to Earth. And it's most efficient. It's the Oberth effect that we've talked about before. And so each time they make a pass around Earth, they do multiple orbits. They blast out some thrust, and they make orbits that are bigger and bigger, and they're shown here. Each one goes out farther and farther from Earth. And at some point, you decide you're far enough, and you do a little extra thrust, and you head off toward the moon. Then they get a gravity assist from the moon. They let the moon pull them around and shoot them off toward Venus. So they're doing the same thing here that they did on this previous mission that they'd done before called Capstone. You may remember that one. That was the one where they were going to try out the orbit, the Lunar Gateway, which is the NASA space station for the moon. That one's going to be in a kind of an unusual orbit. And they really wanted to prove that you could actually be in that orbit without consuming too much fuel to stay in that orbit. So they did a really small satellite, and they actually used this, and they did exactly the same thing. This diagram was actually taken from their literature on that previous mission, but the new one is pretty much the same, except what happens out here, you come over to the moon, and instead of them going into a lunar orbit, they go shooting off to Venus. Photon is the name of their spacecraft. It actually only weighs about 37 pounds, the spacecraft itself, and it's got a small probe, which is 45 pounds, that's attached to it, and it's 16 inches across. So we're talking about something that's not terribly big. You know, you can pretty easily pick it up. So obviously, it's pretty limited. This is not as sophisticated a mission as a lot of the big NASA projects that do cost a lot more. This is what can you do for a very small amount of money, and this is what they can do. So basically, the thing's in kind of a cone shape. as it goes down through the atmosphere, it's shaped so that it'll stabilize going down, as shown on that diagram. There's a pressure vessel that contains all this stuff because you're going to get higher and higher pressure. But the key instrument is this little one that's shooting off the left-hand side here. That's a laser. And what this thing does is it shoots a laser into the cloud, basically the particles, the droplets that are in the air, and it looks at the diffusion. It senses the diffusion. And from that, they apparently can draw all kinds of conclusions. This is called a nephelometer. I had to look that one up. It's just a particular technique, and it's used for various things on Earth as well. They can draw conclusions about the materials just by the diffraction of the light. And then, in particular, because of the frequency of the laser, some organic materials will actually glow. And that's not the phosphine that some people might want to find, but they can figure out some of the composition of the atmosphere from that. They only have about 3 to 5 minutes. They're going to be coming down toward Venus at 37 miles. That's where the action starts to happen. They really start paying attention. They're transmitting data back. And as it falls down to about 28 miles, they're sending as much data as they can. It's a pretty low bandwidth, so they have to really compress that signal. That's one reason they're not doing a whole lot of instruments. They probably didn't have the bandwidth to send back much data anyway. What's interesting is Peter Beck, who is the CEO of Rocket Lab, he says this is basically a nights and weekends project. Now, can you imagine working at a place where, where in your nights and weekends, oh, by the way, we're building a probe, we're going to Venus. You know, it's a little different. Now, that's not completely fair because he's talking about his own people. Now, actually, MIT had a big role in this. They have grad students, they're really cheap. They're cheap and smart, I mean, especially at MIT. So that and students, they probably had 30 people involved at one time or another, all part-time. But, you had a fairly large number of people working on this. So they got some outside help. It wasn't just all of them. Rocket Lab is pretty much providing the means to get there, which nobody else would have provided. So they're getting that. And actually, Ames Research Center of NASA did help out some. They provided the thermal protection, which is a key thing for this because, as we said, Venus is a very, very hot and unpleasant sort of place. So they needed all the guidance they could get. Anyway, the cost is probably less than $10 million. By space travel standards, that's so minuscule. That's less than the cost of any normal rocket launch. So pretty impressive. Okay, that's it for the main topics. Just a couple of things on notable launches coming up. We already talked about the Starship Flight Test 6. We haven't talked about Blue Origin. Their New Glenn, which is their big Starship competition, that might go up this month. Now, that's had a lot of delays before. And originally, they were going to have a couple of small Mars satellites were going to go up with them as part of that launch to tag along. That got delayed just because the launch window closed, and they probably weren't going to be ready. One new thing that came out recently, though, is they are going to be landing on a barge. They're going to do the kind of thing that Falcon 9 does. They're going to land on a barge instead of going all the way back. So whether they do that on the first test or not, I don't know, but they might. It's actually conceivable. They tend to play things so close to the vest, you just don't really know. We talked about the Rocket Lab Venus mission and the intuitive machines. Amazon's Kuiper project. This is the one where it's going to be a Starlink competitor, thousands of satellites up there for communications. And of course, that's taken them forever. Their first operational launch, actual operating satellites, besides the tests that they've done, should be going up sometime first quarter. It's coming. Dream Chaser, we talked about that one before too. That's a space plane, but they're still hoping to use that at least for cargo on the space station. And of course, the big one coming up is Artemis 2 eventually on their journey around the moon, and we can't tell when that's going to be.
There was a question about the Orion heat shield problems holding up the Artemis 2 lunar mission.
No, that was interesting. Orion is a spacecraft that the astronauts go from Earth orbit out and come back. They go down using a Starship and back up, coming back on Orion. It's a very complicated system. Anyway, in their first test, when they brought it back to Earth, they kind of kept it a secret for a while, but there were huge potholes in it, essentially, in the heat shielding. Apparently, big chunks of it got torn out, and that raised a big concern. So NASA has announced that they have figured out what happened, but they're not saying what yet. They said they want to do a little further analysis and testing. So you kind of wonder what's going on there. It's quite possible that by the end of the year, we'll know more about this, because it impacts a lot what's going to happen. Because if they have to really build a whole new heat shield, that delays the whole program quite a bit, especially if they're redesigning it. It's not clear what will happen. So it's fraught with peril from NASA's standpoint in terms of schedule risk, and hence political support and all that. So that's it.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.